So one last kind of property, we have addition or arithmetic properties that allow us to solve equations. We have segment properties that allow us to work with lines and see how lines are related. And we have angle properties. So we're going to go over some definitions for angles. Hopefully you've heard of an angle. But our official definition is two rays with the same initial point. Okay, so we're talking about two rays or lines that go on in one direction that have the same, that initial point. Okay, if I were to call this A, B, C, angle B, or B would be my vertex, the angle is talking about this whole thing, okay? We measure an angle by measuring the inside. Okay, so often you'll see an arc on an angle. Sides are the rays of an angle. So looking at that drawing again, you don't have to draw a different drawing. You can use the same drawing. We have A, B, and C. I have an angle or a ray here, and I have a ray here. And those are the sides of my angle. Those two things come together to make the angle. And lastly, I have the vertex, which is the initial point of the rays of the angle. So the vertex is where are those two rays coming from? In this case, it would be B. B is our vertex. It's where those two come together, and it's where we measure angles. So when we're measuring angles, we're measuring the distance between the sides at the vertex. All right, next I have congruent angles, and if you remember what congruent angles or congruent means, our symbol for congruent is the little tilde with two or with an equal sign, and that means that they are angles with the same measure. So whether they're facing the same direction or not, if these two angles have the same measure, then I would say like the interior, right, is measured the same. Then I would say angle ABC, this is ABC, is congruent to angle DEF. Angle DEF. Okay, if they measure the same on the inside, or that distance between the two sides is the same, then they are congruent. We use the congruency symbol instead of an equal sign to say that they are different things. They are not the same thing. They are created by different points and different rays, but they measure the same. So that's our indication that they're not necessarily the exact same thing. They're not facing the same way or made of the same points, but they are in fact the same measure. Speaking of measures, my first measure is an acute angle. An acute angle is an angle less than 90 degrees. So that is anything less than 90 degrees. So there's an acute angle. Here's an acute angle. Here's an acute angle. Okay, it almost is up to a right angle or a 90-degree angle, but it's not. So it's our skinniest or thinnest angles. Okay, Our next angle is a right angle. That is an angle that measures exactly 90 degrees. And we indicate it by drawing a box at that angle. So instead of a curve, we have this box. Okay, so regardless of which direction my right angle is facing, if I have this box on it, I know it's 90 degrees. Even if the drawing isn't 100% accurate, if it has that box on it opposed to an arc in the angle, it is a 90-degree angle. Next, I have an obtuse angle. This is an angle more than 90 degrees, but less than 180 degrees, which is a straight line. Okay, so this is anything more than 90 degrees, but not a straight line. It could be really close to being a straight line. It could be really close to being 90 degrees. But if it doesn't have that square in it, if this is 91 degrees, okay, if this is 179 degrees, as long as it's between 90 and 180, it is an obtuse angle. Next, we have a reflex angle. This is an angle, any angle, more than 180 degrees. So if I draw an obtuse angle, it's the angle on the outside. That's my reflex angle. So the inside is less than 180. So the inside is always an acute or obtuse. The reflex angle is always whatever is left over. So if I have this little acute angle here, this is my inside. My reflex angle is what's on the outside. And it completes the circle. So it's the other half of your angle, or the other piece of your angle, I should say. Lastly, we have adjacent angles. And adjacent angles are angles that share a ray. So if I have something like this, and I have A, B, C, I should make these rays, and D, angle ABC, and we always put the vertex in the middle. I should have said that earlier. The vertex always goes in the middle when I'm writing out my angle, is adjacent to angle CBD. Okay. So because these share the side C, they are the same angle. Or they are, sorry, not the same angle. They are adjacent angles. Okay. Now we have the protractor postulate. And what that says is that the measure of an angle is the distance between marks on a protractor. Okay, meaning that wherever my protractor lies, if I have my protractor, that's that tool that looks like this, and my angle, I'll use a different color for my angle, is here to here at 50 degrees and 110 degrees. then my angle measure would be 110 minus 50, which is equal to 60 degrees. So this is my example here. So I take wherever it measures and find the difference between them, and that is the measure of my angle. Oftentimes we line up our angles at 0 on a protractor when I'm using a protractor, because it helps us to get those angles a little bit easier, but we don't necessarily have to line them up at 0. What this is saying is I can take the difference or subtract them, and it will give me my angle measure. Lastly, I have my angle addition postulate. This is what's going to be most helpful for you in your proofs. So if I have angle X, W, Y, and Z, what this says is that angle XWZ is equal to, which is this whole thing, is equal to the part XWY plus angle YWZ. Okay. So the part plus the part equals the whole. Okay. My example for this would be if you have an angle that you know is 60 degrees, and I have this piece coming out of it that is 20 degrees. 60 is equal to 20 plus the other one would have to be 40 degrees. So you can get the total from the pieces. Okay.